Howdy, everyone. Just going to go over the questions that people have requested, or at least some of the questions people have requested. Indeed, someone requested almost every question, so I sort of picked a representative sample. But if you have more questions that are specific to some other piece, feel free to say so in the chat. The first question was about 41C, and 41C is done entirely in the beginning of the last office hours video. So if you just flip back to that one, you can see all of 41C. Okay, next, 43C. Okay, so 43C asks for places where the tangent line is horizontal to the graph of h of x equals cosine of x over e to the x. Okay. And we want all the points that are in the graph where the tangent line is horizontal. So there are two in the graph. One which has a positive x and one which has a negative x. So we'll have to keep that in mind as we go through this. So to find places where the tangent line is horizontal, we need to take the derivative and then set the derivative equal to 0. So this is a quotient rule question. So because of that, we have the derivative here is minus sine of x times e to the x minus cosine of x times e to the x, all divided by e to the x squared. I can cancel one of these e to the x's in the denominator with both of the e to the x's in the numerator. Basically, that's saying I can factor this e to the x out of both of these and then cancel it with one of the ones from the denominator. And I can factor a minus sign out of the front. Okay, I want to know when this thing is 0. And so in order to figure that out, I need to figure out when the numerator is 0. So I'm going to take sine of x plus cosine of x is equal to 0, which is going to give me, I'm looking for places where sine of x and cosine of x are negatives. And if you look on the unit circle, that will be at x is 3 pi over 4 and x is 7 pi over 4. However, if you look back at the graph, you'll realize this is not the x value that shows up in the graph. This one actually is in the graph, but this one actually shows up with its negative counterpart. And so this is actually showing up in the graph not as 7 pi over 4, but as minus pi over 4. So if you come back and look at this, then that means my 2 points here where the tangent line is horizontal are minus pi over 4, comma something, and I'll fill that in a second, and 3 pi over 4, comma something. And I get the somethings by plugging in the values of x to the original function. So cosine of x, or sorry, so cosine of minus pi over 4 divided by e to the minus pi over 4, and cosine of 3 pi over 4 divided by e to the 3 pi over 4. So that is the answer here for 34C. Sorry, for 43C. I'm going to give just a minute, since there was a lot there, in case someone in the chat wants to ask any questions about that, and then I'll do the next question people asked about. Okay. Next up, 44. Let's see, so 44 is asking to find the spots on the graph where the tangent line is parallel to the shown line. So let's do 44b first. This is secant of x plus 2x. And the given line is y equals 2x minus a half. And let's just remember, what does parallel to this line mean? It means it has the same slope as this line. So parallel to this line literally just means the slope is 2. So I know this is often a little bit disconcerting when this happens, but this minus a half actually has no bearing in the solution of this problem. Okay, so we need to go ahead here and take the derivative first. So this will be the derivative of secant, which is secant of x tangent of x, plus 2. And we need to set this equal to the slope we want, namely the slope 2. So most of the questions we've done here are take the derivative, set it equal to 0 questions. In this question, this is a take the derivative and set it equal to 2 question. So I want to solve secant of x times the tangent of x is, plus 2 equals 2. So I can subtract the 2 over, so this will give me secant of x times tangent of x equals 0. So the solutions here have either secant of x equals 0 or tangent of x equals 0. Secant of x is 1 over cosine of x. So in fact, if you remember, again, if I want a fraction to be 0, I need the numerator to be 0. Well, 1 is not 0. So therefore, in fact, this is never 0. So this never happens. Okay. If you pull up a graph of secant of x, or I guess look at a graph of secant of x, you'll see it never crosses the x-axis. In fact, secant of x is always either larger than 1 or less than minus 1, so in particular, it's never 0. Flipping over to this side, tangent of x is sine of x over cosine of x. So tangent of x is 0, where sine of x is 0. And where sine of x is 0, well, in between 0 and 2 pi, it would be 0 pi and 2 pi. But as is somewhat a theme in these questions, it's asking for the points that are actually in the graph. And so we have to identify which of those points there are. And it looks to me like there are two, one of which is at x equals 0, and one of which then would have to be at x equals pi. There do not appear to be any negative ones in this particular graph. So then I can find the matching y-coordinates by plugging in these values back to the original function. Okay, we also had a question about 44C, where the question was more specifically about what happens when you go to actually solve this. So it's the same style of question. Here is h of x is sine squared of x. And y is 1/2 x minus 2. So so we need to take the derivative and set it equal, in this case, to 1/2 and solve it. Okay, so here, in order to take the derivative of sine squared of x, we need to remember that that's sine of x times sine of x. So h prime of x is sine of x times cosine of x plus cosine of x times sine of x, which is 2 sine of x times cosine of x. And we need to know when this is 1/2. So we'll set 2 sine of x times cosine of x equal to 1/2. Okay. This is the product rule I used here, by the way, because it's sine times sine. Okay, so now when you look at this, you might be tempted to move the 2 over, and then you get sine times cosine as a quarter. And that ends up being super unhelpful. The thing that's actually helpful is to realize that this thing that's appeared is, in fact, sine of 2x equals 1/2. So when you look at this, we know how to solve this. Here I'm supposed to write down the things where sine of that number is 1/2. So sine of pi over 6 is 1/2. Sine of 5 pi over 6 is 1/2. And those are the ones between 0 and 2 pi. So here we have to go back and carefully look at where the ones in the picture are. And so looking for spots where the tangent line is parallel to the given line, it does look to me like there are 2 positive ones, but it also looks to me like there is 1 negative one, which is right over at the very end. And so Oh, sorry. There are... Sorry, not 2. There are more than 2. Let me pull up this picture real quick so that I can point at stuff, because I don't think if I just say this out loud, it's going to be super clear what I'm counting. Just one moment, please. Sorry about that. That took me a moment. But let me go ahead and try to show you the thing that I was, or the points that I was talking about. So I'm looking for points on this graph where the tangent line is parallel to this given line. And I can see there's one of them in there. But there's also one of them in there. So in fact, there are 2 here, just in the first half of the first wave of whatever you want to call this. Okay. Now there's another one there, and maybe even another one there. I will fully admit, by the way, that in this graph, it is not crystal clear whether there's one just to the right of where the graph ends or just to the left of where the graph ends. And the same, unfortunately, is actually true over on the left side. So I actually could see you either including a point on the far left and a point on the far right, or not including them, and I would be happy either way, because it's my fault that the picture is a little ambiguous as far as where the graph actually starts and ends. Okay. But all of that was by way of saying I definitely have at least 1, possibly 2 more points to find in this direction, in the positive direction. So when is the next time that we get to sine being equal to a half? Well, that is at 13 pi over 6. Okay. And then the next time would be 17 pi over 6. And if you want to grab the one that's negative, you would say, okay, what's the one before this one, which would be 2 pi before 5 pi over 6, which would be minus 11 pi over 6. So again, these 3 are definitely something that's in the graph. And then depending on exactly how you read it, these 2 are either just past the edge of the graph or just before the edge of the graph. Okay. So how do we solve this kind of thing? Well, I know the things I now want to put into sine, so I just solve 2x equal to each of these things. So I solve, for example, 2x equals pi over 6. and that will give me x equals pi over 12. 2x equals 5 pi over 6, and that will give me x is 5 pi over 12. Okay, and so on for each of these. And that'll give me the x coordinates, and then to get the y coordinates, I just go ahead and plug these things back into the original function. Whoops, what did I open? Okay, and last up, oh, sorry, no, there's two more, 45C and 46C. 45C, and let's see, what is this question? This asks for the max and min value of this function on the interval 0 to 2 pi. So we have here, sorry, this is 45C. So h of t is equal to 2 cosine of t plus the sine of 2t. And we want the max and min value on 0 to 2 pi. And so because it's asking about the max and min value, that goes ahead and tells me that this is a closed interval method question. Okay, so I should keep that in mind. Now, I'm not going to be able to take the derivative of this with this written as sine of 2t. In fact, what I'm going to have to do is I'm going to have to use my formula for sine of 2t, the double angle formula, if you like, to rewrite this. So I'm going to rewrite this as h of t equals 2 cosine of t plus 2 sine of t cosine of t. Okay, so I can now go ahead and take the derivative here. So this will be minus 2 sine of t. And now I need the product rule for this part. So plus 2 cosine of t cosine of t. And then plus 2 times sine of t times minus sine of t. Okay, so simplifying that, I will get minus 2 sine of t plus 2 cosine squared of t plus, minus 2 sine squared of t. And I need to know when this is 0. Now, we talked about a lot of sort of specific tricks that you could use when you're solving a trig equation if you don't sort of see how to do it right away. This requires one of those tricks. Namely, this particular equation currently has both sines and cosines in it in a way that is not helpful. So what I actually have to do is I have to rewrite this piece in terms of sine. So namely, remember sine squared plus cosine squared is 1, so cosine squared of t is the same thing as 1 minus sine squared of t. Okay. So in other words, I can rewrite this whole equation I'm looking at like this. Now I'm going to rewrite this in the usual order, so sine squared at the front, and I'm going to divide everything through by -2. So this will become 2 sine squared of t plus sine of t minus 1 equals 0. Okay, so now what is this trick? Now we have to use the other trick after we use the trick with the cosine squared. Namely, we have to use the trick factor this. Okay. So how do I factor this? Well, one of the terms is going to have a 2 sine of t. One of them is going to have just a single sine of t. And I'm going to squint at this for a second and say that I need a +1 and a -1. Okay. All I did there was to sort of mentally say, okay, if, say, t is sine of t, so big T is sine of little t, then this whole equation is really asking me, when is 2t squared plus t minus 1 equal to 0? And so then I just factored this as we would any quadratic, and then put the signs back. Okay, so let's go ahead and solve each of these pieces being equal to 0. So the first piece is 0 when? It's 0 when 2 sine of t is 1, so when sine of t is a half. Okay. Now, in this particular interval, we're only in this particular problem, we're only talking about the closed interval 0 to 2 pi, so I don't have to do anything fancy. This just translates immediately to t is pi over 6 and 5 pi over 6. Okay. And then the other thing was sine of t plus 1 equals 0, so that's saying sine of t is minus 1. And so that's going to tell me t is 3 pi over 2. And ergo, I am supposed to look at the values h of 0, h of pi over 6, h of 5 pi over 6, h of 3 pi over 2, and h of 2 pi. Okay. These three because they're places where the derivative is 0, and these outer ones because they're the endpoints of my interval. Okay, now we could just plug all of these in and evaluate it, and that's fine. But I did tell you last lecture, and this is worth remembering, we can use the graph to sort out which of these is actually biggest and which of them is actually smallest. Give me a second to find the graph and pull it up on screen again. Okay, here it is, the file that I appropriately and helpfully named trig graph 26. But this is the graph that you're shown there in the question. And so I want to think again about where each of the critical numbers is. So first of all, the endpoints. That is the endpoint at 0. That is the endpoint at 2 pi. I can just read those off the graph. And then where is the tangent line to the graph horizontal? That's one of them. That's one of them. And that's one of them. Okay. Note this one might be a little sneaky because this one's actually a kink, not a local min or a local max. That's the rarer of the flavors of critical number, but this is indeed the third critical number. And so that means this is the input x equals pi over 6. This is the input x equals 5 pi over 6. This is the input x equals 3 pi over 2. Now, I am allowed to look at the graph and see which of these things is biggest. And that's the biggest one. So I'm going to just go ahead and write max here. That's from the graph. And this one over down here, that's the min. So in order to complete the question, I have to go back and actually calculate what those are. So h of pi over 6 is, and so now I have to go back to the definition of h. Which is that h is 2 cosine of t plus sine of 2t. So this is going to be 2 cosine of pi over 6 plus sine of, and then 2 pi over 6, I'll just go ahead and write as pi over 3. So this is 2 times root 3 over 2, plus, and that's root 3 over 2. And so that is 3 root 3 over 2. Okay, so that is the max value. And then the min value happens at 5 pi over 6, where I get twice the cosine of 5 pi over 6, and then plus the sine of 5 pi over 3. Okay, so this is 2 times, and so the cosine of 5 pi over 6, you can convince yourself, is root 3 over 2. Sorry, it's minus root 3 over 2. Plus, and then the sine of 5 pi over 3, that is minus root 3 over 2. And so the min value here is minus 3 root 3 over 2. Okay, so that's what those questions look like when you end up using the graph to help you with the very last step. Okay. Let's do 46C next, but I'll pause just in case there's any questions. 46C. Let's have a look at this one. Okay, so this one asks about intervals of increasing and decreasing. And our function here is h of x equals sine of x plus cosine of x all squared. Okay. So we want, so again, we want the intervals of increasing and decreasing between 0 and 2 pi. So this is a first derivative test question. Now, before I take the derivative of this, I want to simplify it. And the reason for that is going to be clear after I do, because this is going to, after I FOIL it out, be sine squared of x plus 2 sine x cosine x plus cosine squared of x. Sorry, that's a plus cosine squared of x, if you cannot read the bunched up handwriting. But the point is, sine squared plus cosine squared is 1. So this is, in fact, 2 sine x cosine x plus 1. Okay. Now, important note, this is not the derivative. This is just h of x. So I still have to take the derivative, but I'd much rather take the derivative of this than take the derivative of that. So using trig identities has saved us some amount of work here. Okay, so if I use the product rule here, I get this. Note the plus 1, the derivative is 0 because it's a constant, so that's just going to drop out in this piece. So this will end up being 2 cosine squared of x minus 2 sine squared of x. And so we can solve for when this is 0, which is going to look like 2 cosine squared of x is equal to 2 sine squared of x, or cosine squared of x is equal to sine squared of x, or, and I can take the square root of both sides, which is going to give me a plus or minus, cosine of x is equal to plus or minus the sine of x. Okay. So I'm looking for the spots on the unit circle where either cosine and sine are the same, or where cosine and sine differ only by a plus or minus sign. So that is, I'm looking for the places where the coordinates are plus or minus root 2 over 2 and plus or minus root 2 over 2. When you pull out your unit circle and look, you'll find out that those happen at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And ergo, having had these work out in this fashion, we can go ahead and make our number line. So our number line here is going to start at 0, and then it is going to have these breaks here at each of these critical numbers. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now, this question's actually really well set up for us to just do our usual thing, which is to pick a test point in each interval and plug it in. You can do that. It's fine. You'll get the right answer. Everything will work out fine. Okay. The thing I wanted to show you is the fact that I mentioned that also you could do these questions from this point by looking at the graph. So give me a second to fish up the graph of this function. Okay, so here's the graph of this function, and I want to make this line up with my number line here. So again, I'm supposed to have my little critical numbers here at these points. So that looks to me like the first critical number between 0 and 2 pi. So that must be pi over 4. So this corresponds to that point on my number line. Follow this on down. That's the next critical number. That must correspond to 3 pi over 4. Then follow this one up. Whoop. There we go. That must correspond to 5 pi over 4. And then that one must correspond to 7 pi over 4. Okay. So the point is, I can read off exactly where the changes in increasing and decreasing are by combining looking at this graph with looking at my work on the number line. And so in particular, when I'm trying to fill in the behavior of f of x here between 0 and pi over 4, that's the same as this piece of the graph. Well, I can read from the graph that the answer is, on that piece, the graph is increasing. Then for the next piece, that's between pi over 4 and 3 pi over 4, that's those places, the graph is decreasing. And then the next piece, between 3 pi over 4 and 5 pi over 4, it's increasing. Then between 5 pi over 4 and 7 pi over 4, it's decreasing. And then between 7 pi over 4 and 2 pi, it's increasing again. And so that lets us write down our final answer here, which is that this function's increasing on 0 to pi over 4, 3 pi over 4 to 5 pi over 4, and 7 pi over 4 to 2 pi. And that it is decreasing on pi over 4 to 3 pi over 4, and 5 pi over 4 to 7 pi over 4. Oh, sorry, I realized I wrote that under the thing. I will take away the graph so you can actually see that. But all I did was read off the things that I wrote down here based on the graph. All right. That's the questions that were requested, or at least a representative sampling, so that you can have some of me working through every kind of question to look at and look at the graphs and see how that sort of works. But if you have any more questions, I'll be here another hour or so, so go ahead and post them in the chat, and I will answer them.